I hope you enjoyed the keynote yesterday. I think it was very interesting, the whole flow. And as you know, there's some cool stuff that is happening in the serverless space. There's other announcements that I'm not covering, like nested serverless apps, or the WebSocket support for the API gateway. This session will focus on layers and also on the new Runtime API. So, a couple of words about myself. So I'm Danilo, I'm part of the evangelist team, and I'm focused on serverless worldwide. So my purpose is really to help people understand the value of serverless and what it can provide to them. And the idea today is to go in this order. So first, see how layers work. Then, to see how the Runtime API works to bring your own runtime so that you can bring your own programming language. And then we will do a demo. Probably this will cover a lot of the time of the session to see how layers work and how you can create a custom runtime for a new programming language. So first of all, Lambda layers. So Lambda layers is a way to centrally manage code and optionally also data that is shared across multiple functions. So currently, when you have, for example, the same library, the same framework that is used in multiple Lambda functions, you have to package the same library into each function. So it's something that you have to do outside of the Lambda platform. With Lambda layers, we are going to simplify that. We are simplifying that because it's already available in the console. So the idea is that really you can use this to share custom code and also all those libraries, modules, frameworks that we use with our programming languages. So I think there are a few benefits here. So the main benefit probably is really to create a separation of concerns between who is writing the business logic of the function that is in the function code and maybe who is managing the low-level libraries that can be maybe including modules for system management or tracing. So this is really creating eventually a new role. It's making the function code smaller and more focused, because now if you work with a function, we will be able to say use those layers that include all my dependencies, and my function code will be very small, maybe easy to manage, and also the deployments are much faster, because currently if you need to redeploy a function and you need to change maybe one line of code, you still need to bring all the dependencies that could be megabytes. Now you can just reference a layer and just re-upload the single file that is maybe including the function code. The idea is really that the function code becomes more and more focused on your business logic, and everything that is not business logic will be in the layers. And layers can be reused across multiple functions. So how can you use layers? So layers, like functions for Lambda, are a zip file that you upload as a Lambda layer. And when you upload a layer, so you say this zip file includes my layer and I want to create a new layer, you automatically create a new version. And we manage versions exactly in the same way we manage versions for Lambda functions. So when you create and upload, the first layer version will be version 1, then version 2. Those versions are immutable, so you can't update a version, you can only create a new version, and we will create the new number for that version. There is no concept for now of aliases. So if you are familiar with version and aliases in the Lambda platform, there's no aliases. It's something we are thinking about, so happy to get your feedback. For now, you only have versions, and in the when you create a function, in the function configuration, you can link the layer and the version that you want to use. So if you want to update a layer from version 2 to version 3 in your function, you need to change the configuration and change the version number of the layer. When you delete a layer, you can't use that layer anymore in new configurations, but every configuration that was done before the deletion will stay there and will continue to work. So let's say that I have version 2, when I create version 3, I delete version 2 of my layer. All my functions using version 2 continue to work, and that layer will be preserved by us, but it will not be usable. So if you try to configure that layer, version 2 will not, you will get an error. You need to use at least version 3. If you and you will see this has also an impact on how you manage space how we manage space in the Lambda factory. So when you create a function, you update a function configuration, you can add up to 5 layers. 5 is an arbitrary number that we decided because it's probably a good compromise. We don't want to have too much layers because that can slow down the deployment of a function. Again, we're open to feedback. That means that if you're using, for example, Node.js, probably you don't do a layer for every NPM module because it would not be efficient. You probably create a layer for your standard shared libraries, maybe a management layer where you put all the management stuff that you need to use, like tracing, monitoring, and so on. So I expect people to use 1, 2, 3 layers per function, not more. When we invoke the function, the first time when we have to create the environment that, as you know, now runs inside Firecracker, the micro VM, we will take all the layers and we will install them locally, and I will explain how that works. The overall maximum size of the deployment package remains the same, so it's not changed. So the layers will count into the size of the deployment. So currently the maximum limit for the uncompressed deployment size is 256 megabytes for a Lambda function. And with layers is the same. So if you have a function that is 200 megabytes and then you add a layer that is 100 megabytes, you reach 300, that's too much, you get an error. So you need to stay within. So you can't use layer to add more things in your functions, just for creating a more modular approach. By the way, it's a small audience, so if you want to ask questions, happy to take any questions. So when you configure those up to 5 layers, this is not a set, it's an ordered list, because order is important. Because when we create the environment, we will unzip the layer, so the layer is a zip file, under /opt, and we will use the order that you provide. So each layer can potentially override the previous layer. It can make sense sometimes, but order is important. And you will see that you can choose the order. So for example, we expect that you may have a first layer that maybe is a custom runtime, like the PHP runtime that Stacker is working on, or the C++ runtime that we released yesterday. Then you add maybe a layer with your custom libraries, and then you can add another layer that maybe is overriding a version of those custom libraries for your specific function. So this is how it works, and why the current layers fits very well. And the storage of your Lambda layers takes part to the limit of the storage that you have in every region. So currently with Lambda functions, you have 75 gigabytes in every region. And now that you have layers, the size of the layers of all the versions of the layers, like all the versions of the function, must be below 75 gigabytes. As you know, there's no cost for this storage, but we have a limit. If you delete a version, if the version is still used, as I said before, we preserve the version, so it will still be counted. So if you delete a version to free some space, it may not necessarily work if another function is still using that version. When no function is using a version, we know that, then we will release the space. How do you include modules for your function? So the idea of layers is that the function code is not changed at all. So if you're using Python or Node.js, you can import or require. If you're using Java, you can just add the stuff in your code. So to do that, we have some environmental variables depending on the platforms. But the idea is that under /opt, so this is the directory structure of your zip file when you create a layer, must follow these rules. So for example, let's say, and we will do a demo, I want to create a layer with some node modules. You must have a zip. When you unzip it, it creates Node.js /node modules, like it would npm install, and then all the modules that you want to use. For Python, you must have a directory that is Python, and then all the Python modules. Or if you want, we support also the syntax with Python version, so that you can create a single layer that can map, depending on the version of Python, to the packages for version 3.6 and 3.7, for example. For Java, Java/lib is the class path, so you put your jars there. So when you unzip the layer for a Java function, you must create a directory that is Java, and then a directory is lib, and there you find all the jars. For Ruby, we have two ways. If you use libraries or if you use gems. And for any language, if you want to include your own binaries that are executable, you can put them under bin. So /opt bin will be in the path. And if you want to bring binary libraries like shared objects for a Unix platform, that should be under /opt lib. So you must create in your zip file a lib / and then something. Is this clear?
Yes.
Okay. As you see, there's no .NET, because for how .NET works, this doesn't make sense. So .NET for now can't use layers. So how permission work is you can have link permissions to a layer, and you use the standard resource-based permission model of IAM, and you can give a principal that can access these layers. So by default, layers are only used within the AWS account, but then you can share with other accounts, and it's integrated with AWS organization, so you can very easily say, I want to share this layer within my whole organization, and all the accounts within an AWS organization can read and get that layer. Or you can share publicly with the principal asterisk, like you can do with an AMI, with an EC2 AMI, and then you can share layers with the broader community, and this is something that we expect providers to do to create a standard library of layers. We are also publishing our own public layers to help you set up and do things easily. For now, the only layer that we publish publicly is for Python, and it's including NumPy and SciPy, and that's the one that I used in the blog post. And the reason why we did that is because we got lots of requests, and because NumPy and SciPy, that are two scientific libraries, they also have binary dependencies, so there are a few C++ libraries that you need to bring with you, so it's always been a pain for customers to do that. So that's why we are happy to say now you can just take the layer and you can start writing Python function using NumPy and SciPy. And it's pre-built and optimized for the Lambda environment.
Do the public libraries count against your 5 layer?
Yes. I'm not sure if they count in the 256 megabytes. So let's assume yes. There's some internal discussion because the idea is that we can brainstorm them. But for now, consider that they count. There's the possibility that AWS shared libraries will not count into all of the space.
And follow up on that, is X-ray going to be considered for a library?
It's something that we are definitely considering. It's a little bit small for a layer. So as I said before, if I am a company, I would probably have a management layer where I put X-ray, and maybe if I use New Relic, I put something for New Relic, if I use other management platform. So, but to create it is very easy. So I will create a layer. So if you want to do that yourself, it's very easy.
So doing this, .NET support functions like
.NET doesn't make a lot of sense because I was chatting with my colleague. .NET is building anything together. So for that part, we are already talking with some customers to understand how we can map this approach with .NET, because currently it doesn't match. It's a different way of packaging things.
So the layers, when you say shared publicly with the broad developer community, is there a sort of a repository or a marketplace or something like that?
So for now, you need to publish the ARM. So what you can do now, there is no repository. What you should do now is to say this ARM is public, so if you want to use it, you can use it. It can be simplified using the serverless application repository, so that ideally you can create an alias and people can install that and find your layers easily. But it's something that we're thinking of. So currently the best way is to just advertise the ARM. You will see there is an Amazon resource name for your layer that includes the version. Yes, it's already integrated. So I will show that later, but if you use the same CLI, there's a syntax to specify the layers that your function are using. When you use SAM local, we automatically download in the container all the layers, and we do the order you provide, and it's already there. I still was not able to do some tests because yesterday was the announcement, but it's already in the public branch. So yesterday we released SAM CLI 0.8, and that's including this part.
You might cover this later, so you can just ignore this question if you are. are you going to be covering like Y layers versus like shared libraries that you just include as part of the Lambda?
So I will go fast because we have lots of discussion. I think this is the simple model and it's extending the same concept that we have for functions. So with function you have a zip file. Maybe you don't realize that because you use SAM or stuff, but at the end functions are zip files for us. And this is the same way that, that we want to manage dependencies. And they are independent from the technology. So if you use Java or whatever, you can always use zip file. So maybe we can talk later about this.
Are layers fully supported in CloudFormation?
Yes, in SAM. So I prefer to go on because I have lots of content and then I love to take all the questions and I will also be available after the session eventually. So this is the first part, so API. So we changed a few API in the Lambda platform to update the layers. So the create function and the update function configuration, now you can specify a list of the 1 up to 5 layers. And these are the new APIs where you can use to list layers, list the version of a layer, publish a new layer version. As you see, there's no publish layer. You always have to publish a version. Delete with the caveats that I described. Get layer version is interesting because when you do that get layer version, basically you say, give me information on the site by line on this layer version 3. We also give you a link to a zip file that you can use to download the layer locally. And that's what the SAM CLI use. So that the get layer version is giving you a link so that you can download the full layer locally. And the last 3, you can get the policy or change the permission to share or not share a layer with other accounts. This is how this works in SAM. So this is a standard SAM template, so we declare everything. Then when you create a function, in the properties of the function, you can add layers. And then you have an ordered list of up to 5 layers. This is in YAML, this is an ordered list. So I cannot stress it more, order is important for layers. So we will do this. And this is a list of ARM. And then of course, you know, in CloudFormation, you can get the ARM if you create something. And this is how you can create a layer from within SAM. So there is now the AWS serverless layer version. As I said before, you can create a layer. You always have to create a layer version. And you say, I want to create a layer version with some description. This is the content URI works like for Lambda code. So it can be an S3 bucket or it can be a code that you have locally. We will package and zip it. You can, when you create a layer, you can declare which runtimes are compatible so that you can discover them easily. You can optionally add some license information and retention policy. So this is the description of Lambda layers, and then we will do the demo. Let's move on the runtime API. This is slightly different, but then runtimes use layers to be distributed. So the runtime API is the way you can use any programming language and bring any specific version, for example, of a runtime that we don't have on Lambda. So what happens is that now in the console, when you have the list of runtimes, you can choose a custom runtime. And by custom runtime, we mean a runtime that we don't manage. So the main difference here, and this is important, for the managed runtimes, like Node.js 8, 10, we will automatically do security updates for you. If you have a custom runtimes, this will be probably in a layer, but it's not mandatory, and you are in charge of updating the layer and the runtime. So if there is a security update, we can't do anything, it's your code. So there's an operational burden in managing a custom runtime. What happens is if you use a custom runtime in the API, for example in the CLI, it's called provided. So the code that you have to do using the CLI is provided, the string that is used by the CLI to specify a custom runtime. So what happens is that in the function code or in one of the layer, in the root directory of the function code or in the root directory of one of the layer, there must be an executable file called bootstrap. And as I said, layers override. So we'll first search in the function root. If it's there, it wins. Then we look under /opt, where we unzip the layers, and there must be the bootstrap file. If you have 3 layers, and all the 3 layers have a bootstrap file, the third will be each one will overwrite the other, and the last one will survive. And this bootstrap executable is responsible for the communication between your code, that can use anything you want, and the Lambda platform. And you can use any programming language. And we will see that we are using some environmental variable to communicate with this bootstrap file. I have all the details. So this bootstrap executable is using a simple HTTP interface to get the event. So when there is an invocation, it gets the payload of the event, and then it can return back the response or the error. And when it's not doing that, it's freezed, like with the traditional Lambda environment. So when there is nothing to do, then the process will be freezed. Let's see information more here. What's important? One important part is that you only need to know the runtime API if you want to create your own runtime. If you want just to use a runtime that is provided by someone, you don't need to know all the details. So as a developer, to expect two roles here. There will be a runtime provider that will create the runtimes, and the developer just includes the layer because you can distribute a runtime as a layer, and you don't need to know all the details that I'm explaining now. So the bootstrap executable will receive these three environmental variables. The first two are new. So AWS Lambda Runtime API will be in the form hostname port, will be the endpoint to call to get new events and to send the response back. So this is the main interface for the bootstrap. The underscore handler variable contains the handler of the Lambda function using the normal syntax. So the normal syntax is script name without extension and then function name, the same handler that we always had with Lambda. And this is how the bootstrap will know the handler. And the Lambda task root is the usual variable that tells where the function code is. This has not been changed. So the flow of a new runtime will be, you have some initialization, and you can eventually fail during the initialization of the new runtime. Then it will get an event from a URL. The event will also contain the X-ray tracing ID, and you as a bootstrap provider are in charge of taking this value and put it into an environmental variable that X-ray will see. So if you don't do that, X-ray will not see the tracing ID. You can optionally customize the context object, but it's not mandatory. Then you invoke the function handler with the event payload that you received. You handle the response or the errors, and then you clean up the environment for the next invocation. That's the flow of a custom runtime. So those are the endpoints. So as I said before, you get the AWS Lambda Runtime API that is host and port. So basically, this is the URL that you must use. This date here, this is the date you need to use now is for versioning, so if you want to create a new version. And then the part here is the part that I'm describing. So the bootstrap starts. If you have some errors, maybe you want to initialize something you can't, you can post the initialization error to the init error endpoint. Then you do a loop where you start to get a runtime invocation next, and your function will be freeze, your bootstrap will be freeze, and then when there is an event, we will unfreeze the environment and send you the event. And there are two headers here that you must look for. So the Lambda Runtime AWS Request ID is the invocation ID. And then you get the trace ID for X-ray that, as I said, you need to put into an environmental variable for the X-ray SDK to work within your function. And then with this invocation ID, you can post the response or the error, and the invocation ID is part of the URL. So that's why you need to store it. Make sense? And this is the full endpoint that you normally use. So we already released this runtime. So as AWS, we released yesterday the C++ and the Rust runtime. One is described in the compute blog, one in the open source blog. And they are also linked in the main blog post on the news channel. And we are working with our partner to release Erlang, Elixir, Cobol, that's an interesting one. NodeSource is also building a NAND-solid distribution, is a robust Node.js distribution, and also with Stegli we're working on PHP. This is the same interface that now we are going to use also to build the standard AWS runtime. So for example, the Ruby language that is fully supported, and we released it yesterday, it's using the same API as here. So you don't get any performance slowdown by using this API. It's the same that we are going to use starting from now. So the speed is great. So let's see how this works in practice. Yeah, so I have to send that part. So first thing, I want to show an example with Node.js, then an example in Python, and then we go to create a custom runtime. So let's start with Node.js. So this is the Lambda console. Let's see the network works. Okay. As you see now, you have layers here. Let's make it a little bit bigger. And let's start by creating a function. I want to create a function that is Node.js, so let's call it Node demo. I want to use Node.js 8. As you see here, you have the custom runtime. But I just want to use layers now, so Node.js. I create a new role. I normally create a role with the same name of the function so that I can delete them easily. And I don't have to add any permission for now, so I just create this empty function. And then here I have some code that I want to use. So let's start with this here. Let's copy and go in the Lambda console. So this is a very basic Node.js example, but I want to use these two modules. One is moment, that is very common time libraries that does time difference, these kind of things. And then request, this is super common, where it's a HTTP library that most Node developers use to call other websites. And then I'm using this library to get the current date and format, and also to download the AWS.amazon.com website into a variable. So if I try to save this and run it, of course it will fail. Let's create an empty event for the function. Test. And okay, can't find module moment, of course. So let's create this as a layer. So I go here. And for now, this is just, I already have the solution. I already have an empty Node.js, no, a non-empty, sorry. So I just need to create a Node.js directory. And then inside Node.js directory, I just do npm install moment. There is now a package log file that I don't need, so I move it move package into the directory. And if I look into Node modules, moment is one of the few npm modules that doesn't have other dependencies, so it's just this directory. So now I go here. We will see with request, it's fun. So here now I just zip it. I zip it using maximum compression, the old Node.js path. And I put it into a file that I call moment layer. This, of course, you can automate it. So if I do unzip on the file, I see that the structure is Node.js, Node modules, and then all the modules that I want. Now that I have this zip file, I can go here, go into layers. I create a layer. You can use the CLI, of course, or you can use SAM. I can create this as a moment layer. The description is where it is for version. So for example, you can use the packages. So I save the packages here because if you look into packages, you know which version was here. So a good practice would be to take this version and put it here. So version 2 point something. Then you can upload the zip file. So this is the moment that I just created. Here you can declare which are the compatible runtimes. So this is not enforced, it's just for discoverability. So you can always bypass the check here. So this should work with Node.js 8 and I think also Node.js 6. And then optionally you can add license information for distribution. So now I'm uploading. This should be 700 kilobytes, so it's very fast. Or I created version 2 because maybe it was already there. And now I can go back to the function. And let's create also the other layer. So I also need to use the request library. So let's do the same for the request library. So I go here. I was pretty sure that I deleted everything, but so let's create the Node.js path. Then I do npm install of request, and I also want to install request promise, that is giving a promise interface for a JavaScript. And this is where npm is fun. So if, again, I move the package into outside because I don't need it, and if I look into node modules to just do an HTTP download out of the internet here. Oh, security is great. Now I can zip this into my request layer, and again use maximum compression because it's giving you benefit. And I'm adding everything. So now I'll go here, I create a request layer. Again, you should probably put the version of the request and request promise module here in the description, that you know which version I'm using. You can also link S3 if you want, so this is suggested for large libraries. And then I go here and I have the request layer. This is again compatible with Node.js 8 and 6, and I create. Now this will probably take a little bit more time, it's 2 megabytes. And now that I have my layers, I can go into my Lambda environment, I can go into my function, and there is this new layers here where I can click, and this is simplifying the configuration from the CLI, so I can add a layer. You can see the ones that are compatible with your runtime, or you can provide an ARN and go straight to the ARN. So in this case, I want to add the moment layer, the version 2. And then I also want to add the request layer, version 2. And as you can see here, you can change the order, because order is important. Don't forget to save. You have this is saving the configuration of the layer. And now we can test the function again. So let's do this and test it. And now if we look in the log, it's just an example. I don't have error, and I print the time from the moment library, and I just downloaded 121 kilobytes. It's been downloaded by this request code. So this is how you can use it. This is an example that is not probably a best practice. Probably, as I said, you don't create a single layer for every module. Also because if you have the same dependencies, you will ship the same dependencies again and again. So create large layers that cover, these are the functional requirements, this is my standard management layer, and so on. So this is the first example that I wanted to show. The second is probably a little bit more interesting, is basically what is also in the blog post, but it is based on Python. So let's create a Python demo. And now I'm using, I think I tested this with Python 3.6, so I don't want to test to risk Python 3.7 on stage, but it should work. This is the kind of thing that clean your vascular system to do a demo. So create a new role again, and I call it like the function. For now, I don't need specific permissions, so I can create the function. And so now the function is the Python one, so it's this one. Let's copy. And I have some parts that are currently commented, so let's paste it. So this is using the NumPy and SciPy layers, so this is Python. As you see, from a code perspective, there's no mention of layers in my code. As a developer, I don't need to know if they are packaged with my function or they are in a layer. I just import them, like they required before. And this is using NumPy to do some matrix multiplication and so on. So again, I can test it, and it would fail. So instead of doing another error, I can save the current function. Then I go to layers. I do add a layer. And now if I look here, I can see the AWS layers. and expect this list to evolve in the future. And I have this one. It's actually for Python 3.6, so I think that's the reason why I'm using this. And again, here there's versioning. So if you need the site to update, you will see more versions here, and you are in charge of updating versions. We can do that for you. I added the layer, I saved the configuration. And if anybody of you tried to use some NumPy or SciPy before, you know that it was hell, because you needed to install the Python package and find the binary shared object to bring with you all the paths. It was really annoying. Now I can execute this, so I zoom it. I do test. Let's create another empty event because I'm not using the event. It's more for testing. Test. And okay, we see here the output. So refresh to show you the execution pattern. Test. Okay, so I don't know why it's not updating here. So this code is basically generating two random matrices using NumPy. Then it's doing the dot product of the two matrices. So it's one of the reasons why you would use a library like NumPy. So this is the dot product of the two matrices, so column by row. And then it's generating 10 random points, between 0 and 1 on the plane. And then it's using a library from SciPy that is called convex hull, that is finding the smallest convex set that includes those numbers. So mathematically it's quite complex, but I can use just the library. So this is telling me, okay, those are my 10 random numbers. And if I want to find the smallest convex set surrounding all those points, I have to connect point 3 with point 6, point 6 with point 2 with point 0, and so on. So this is not really visual. So what people normally does is to add another library that is matplotlib, and let's do that. So to install matplotlib, this is a binary library. How can I do? I can't just create the layer on my Mac because binary, this is not Linux. So I go on the Lambda documentation, and Lambda documentation tells you this is the execution environment we use for Lambda. And there's also an Amazon machine image here, this one, the AMI that we use. So I can just click here, and this opens the EC2 console where I can launch an EC2 instance that has exactly the same environment as Lambda, and then I can build it there. So actually I already did it but I did it in North Virginia, because it's where I was playing before the public release. And if I go here, I can just go in the instances, and I have this making layers. This is an EC2 instance where I installed the packages. So let's do a quick SSH. I think I have the key here. EC2 user. Now I'm connecting to the EC2 instance, and here I created the matplotlib, also the layers. And this is, you see this, here's the Python directory, and here there's matplotlib that I installed here. So what I did pip install. You can use a virtual env for Python, or you can just install and copy the directory. And all the dependencies, I had to do actually 2 rounds because one of the dependency was not public, so even if I started before, I got an error the first time, and then I found the other dependency, I installed it. So I zip everything, and I actually already did that. So if we go here in matplotlib, I have this layer ready to be uploaded. So I can go back into the serverless world from the servers, and I go in layers. I can create a new layer. This will be my matplotlib layer. Versioning is again a good practice, and I should have here the zip file. This is compatible with probably only Python 3.6. I didn't test with others. This upload takes a little bit more because it's 16 megabytes. As per suggestion, I should have probably uploaded to S3 and then use S3. It would be much more efficient than what I'm doing. Okay. but the network is good today. And we have our matplot lib layer. So what can I do? I can now go back into my function. This is the Python demo. I add this layer, so I add a layer. You see now I have AWS layers, and also I have this matplot lib layer that is compatible. I have version 1 of this. And let's save, just to avoid any mistake. And then when I will have a look at the code, there was some part that I disabled that was using this library. And okay, the demo gods, okay. Okay, so here is where I import the library. And then I use an S3 bucket to upload the output image. And if I go here, there is this final part that is now commented, that is basically creating a plot using those points and the convex set to make it visual. And this final part here is very important, and you need to clean the plot. You always have to think when you create these kind of things that the Lambda function will re-execute, and the plot object would be recycled. So if you don't do that, every plot will overwrite the previous plot. So I'm now saving this function. And let's also open S3 so that we can see the image. So I think it's in Oregon. Currently the bucket is empty. I can now test the function. It's a little bit slower because now it's creating the plot and it's uploading. Let's see if the plot is here. Oops. Sometimes when I use this interface, I'm not sure if I save the configuration. Ah, no, sorry. I have an error. The error is that I don't have permission to write to S3. So that was part of the demo, but that's why I have console open. So let's go for Python layer, Python demo. So what we add an inline policy for S3. We need just to write, so we need to do a put object on S3. And we need to specify our bucket just to make it clean. So we can add the bucket is Danilo US West 2, any object, and review policy. Normally this is where I make like a small typo. And now the policy is updated, so I just need to run this again. And test it again.
You didn't create.
I didn't save it?
Yeah.
Yeah, that was too fast. S3, right? Yeah, now it's saved. Usually it takes like, no, I did some mistake. Danilo US West 2, put object, and it's the Python demo. So if I go here, let me check the Danilo US West 2, and now, yeah. So this is the only part that probably you're not interested to because it's nothing new, but yeah, now I think it may have worked.
Okay.
Yeah, you can see that it ran. So I ran it another time because since that was this error, the execution was not cleaning the plot. So the first plot that it does after some mistake is the one with error. So I can click here, convex. I can select the object and open the object and just save it. And we see now the plot of the 10 points with the convex set. And optionally I can go back here, increase my configuration time out to 30 seconds, and I can update my code to generate 100 numbers. And then I can test it again, and you can start to see. So the matplot and scikit-learn, since they do lots of linear algebra, they are very common for machine learning and data analytics. So this is a little bit slower because I'm now running for 100 points. And if we go here and we just refresh, we see that now we have 100 points, and this is the convex set. So this is the demo on layers. And then I want to show you a quick demo on runtime. So for the runtime API, I want to create the runtime that everybody was asking for. So to be able to create bash internet-ready functions. So we need a bootstrap and a hello.sh. Likely I have it. I think bash is good because it's also showing you how this works. So this is my Lambda function written in bash. It's a handler, and then I get the event data as $1, and then I prepare my response with the API gateway syntax, and then I send the syntax back with an echo. And what is fun is the bootstrap file. So people want to take a picture. And the bootstrap file is implementing the logic that I was saying before. So it's not important that you know how bash works. It's just for fun here. So if you see there is some set to set debugging. It's important to get when you get any error. So in the runtime description, we wanted if you get an error, you need to exit from the runtime process and declare the error, so that we recreate the container again. And that's what these first two lines do. Then the source line is importing the handler. So if you see, I know that the handler will be under in the Lambda task root directory, normally var/task. And then I take from the handler that does script name dot function name, I cut and I take the the script name, and I add .sh. So I search if hello.handler is my full handler, hello.sh will be the function. Source will import this function into my bash environment. Then I have an infinite loop where I create, I need to read the headers. So I create a temporary file, use temp, so a little bit unique slide, but it's just because bash is very limited with variables. Then I take the event data using curl. So curl is doing the HTTP request. It's writing the headers here in the headers file that I created, and then the endpoint is the one that I was mentioning before, so invocation /next. And what happens is that your process will be freezed here, so you don't have a timeout for the get, because your process is freezed. We unfreeze it when there is data, and then the get will immediately succeed. So you don't need to think about timeouts. Then I extract the invocation ID from the headers in the Lambda runtime AWS request ID, some logging, and then I build the response and send the response back. So I'm not sure if this is the one. I think I have a slightly updated version in my zip file, but it's not important. So this is the bootstrap file, and the function is just creating something for fun. So let's go back into the Lambda console. So first I create a layer. So it's not mandatory to use a layer for a custom runtime. You can include the bootstrap within the function. It's just that with layers it's much easier to manage. So I create a layer here. Let's call it bash runtime. Bash, I want to write it. I upload this very small bash layer here. And this is not one of the layer configuration compatible. This is not compatible with anything. We actually changed the API. You can now declare with the API that your layer is a runtime, so it's compatible with provided. That is the code that we use for, but it's still not in the console. And this has a side effect that you will see. So I create this layer. I'm uploading the bootstrap. So the bootstrap must be always in the root directory and must be executable. So the zip command on Unix is keeping the file executable, but if you zip it with something else, be careful, because if it does not the executable permission, it will fail. I take the arm from this is the arm, the Amazon resource name. And now I create my bash function. Oops, bash function. This is a custom runtime, so we search for Bootstrap. I create a new role and I call it bash function, like the function, and I don't need permission. And the function. So now you can't use the editor because we don't know which is the language you're using. So you always need to use a zip file. You don't have the editor enabled. So for the bash function, first I add the layer. And now you don't see the layer because there's no layer compatible with this. We solved that in the API, so expect an update of the user interface. The idea is that you can see the layer compatible with provided, that we expect are custom layers. So I have to provide an ARM, so nothing bad, but just a better user experience. I can save, and now I can upload the function that I already zipped. So I go back here, I upload my zip file, or you use S3, so bash function. And if I didn't make mistake, it should work. So let's do a test. Again, I'm not using the event, so empty event. And test. And you get the hello world in multiple languages. And what can we do now? We can do what everybody wanted. Create an API. So I now say, okay, let's create a new API. I think I already have an API, so we can. This is an open API. Let's see. Maybe I may get an error because I created the same API. Now it worked. So now I have the endpoint, and we have this bash internet-ready API available. And I think not. And okay, so that was all that I wanted to show, and I'm really looking forward to see what you're going to build with layers and runtimes. And we have 10 minutes for